Yeah, there's a story behind that, obviously. No, so Mr. Matthew Graber exploited me while I was on vacation drinking with my, and without going into too much detail, I now have an $80 North Korean romper. So thank you, Matt. So the goal here is tonight at the bar to wear it and get $80 worth of alcohol. So, which can we see? Yeah. So yeah, we'll go ahead and. So since. So you will see me wearing that after the talk down at the bar, unfortunately. It's really detailed. You can see his pores and everything, which is, yeah. Yeah. So the original plan was to just wear it 5 minutes during the conference, and then Kennedy kind of screwed me by announcing it during the opening ceremony that I had this romper. So I will be wearing it tonight for more than 5 minutes. So. All right. Can everybody hear me okay? Awesome. All right, we're going to go ahead and get started. So my name is Matt. I'm a security researcher in Red Team at Spectre Ops. When you work with a bunch of trolls, this is the kind of crap that gets created. Yeah, so like I said, I'm a trainer as well. So we give a Red Team training. You know, I've taught at Black Hat the last few years. Speaker, comm lover, researcher, etc. Nothing too crazy. So the short version of what I'm going to be talking about today is going to be kind of an overview of UAC and the history of it, going back from its very first birth to now, and how it's evolved, or how you know, bypasses have evolved. So we're going to start talking a little bit about what UAC is, how the integrity level model works. Then we're going to go into kind of the research methodology. So Matt Graber has done a great job of inspiring me to kind of talk more about my thought process, instead of just showing kind of the cool stuff that I've found, right? So we're going to walk through some of the methodology for you know, one specific bypass. Obviously, methodology changes around different stuff that you're researching. So we'll kind of cover that, and then we're going to go into how the you know, various bypasses have evolved over the last few years, and then mitigations, which there's literally one. We'll talk about at the end, and then obviously demos throughout. So UAC, what is it? Stands for User Account Control. So in the words of a Microsoft blog post, is that it's meant to enable users to run with standard user rights as opposed to being an administrator. So the idea behind it was a standard user can still elevate without actually running as a local administrator. I'm sure all of you in here know that that is not the case in most environments. So when a user logs into a workstation and they're a local administrator, Windows will give them 2 tokens to that particular logon session. This is commonly referred to as a split token admin. So they get a standard token, and then when a user elevates, they get an elevated token, which UAC kind of handles the brokering between that. And if you're not a local administrator, UAC offers over-the-shoulder elevation. And that's when you right-click and run as administrator, and if you're not a local admin, UAC will prop up and say, enter the credentials of a user that has the privilege you're requesting, right? So we're going to be focusing on the split token admin scenario. There are attacker vectors around over-the-shoulder elevation, which James Forshaw actually outlined a little bit in some of his recent blog posts. So we're not going to go in depth on that. We're going to stick to the split token admin scenario. So who cares, right? So yeah, if you land on a box, the user's a local admin, like, why does it matter? It's very easy to defeat or remove this kind of vector. Don't put your user in the local administrators group. For whatever reason, that's a concept that's really hard for most organizations to grasp. So I have never been on an engagement where I haven't seen most users removed from the local administrator group. So we have always had to get around this feature in Windows. So it's going to be there. It's been there. It's going to be there. It will forever be there until people actually start to, you know, do what they need to be doing, which we'll cover here in a little bit. Then there's the delicate concept of security boundaries, which I was totally prepared for somebody to throw a rock at me when I said that. Attackers don't care about them. In the next 2 or 3 slides, I'll kind of go over a little bit of what a boundary is, which there's no actual definition for it. So I'll go over what my derived definition is from some of the sources at Microsoft. So from the famous words of Jessica Payne at Microsoft's Ignite conference in New Zealand, attackers don't care about security boundaries. So what is a security boundary? Mark Arsenovich did a post in 2007 on UAC specifically, and this is the best definition I could get from somebody that's actually at Microsoft, right? So technically, there's no actual definition of this. Mark calls it a wall through which code and data can't pass without authorization of a security policy. Now, it's a very gray area, right? So some might say, well, UAC is a security policy. It's to prevent, users from elevating or users from doing administrative rights without explicitly allowing it. So there's a gray area. I don't think it's a boundary whatsoever. This is also a presentation that Mark gave in 2007, I believe. And this is where at the very bottom he explicitly states that elevation is not a security boundary. So that's why these bypasses are never serviced. Microsoft for the longest time didn't really give 2 craps about it, which is why it just kind of ran rampant for a while. We'll cover towards the end how things have changed, both from the attacker perspective as well as Microsoft's perspective. So before we get too deep into that, we're going to go over UAC on the integrity level. I'm not going to go super crazy in depth because I'd be here for a really long time. But basically, you are assigned an integrity level to your security access token, and that's kind of defined by SID, and that determines what kind of access that your user is going to have. So as a normal standard user, you're not able to delete files out of System32, right? When you elevate up to a high integrity, context, you're then able to do these administrative actions. So the security reference monitor will compare the users and group SIDs. And that security access token to the actual ACL and the object that you're trying to manipulate and determine, are you able to perform that action or not. It gets much more in the weeds than that. That's kind of the top level overview that I kind of put together that might not confuse a bunch of people. There's a lot of really good documentation out there on, the entirely like the security architecture as far as elevation and integrity goes. So integrity levels, there are kind of 4-ish to 5 levels. Typically, as attackers, we only care about, being in that high integrity level. So high integrity is going to, give us the ability to make the changes that we need, that be open handles to processes like LSAS, deleting files, etc. Users are placed in medium integrity by default, and then you've got low integrity, which is very restricted, and then you've got system. So kind of where the gap comes in between as far as getting UAC and getting around it's going to be between the medium and the high. So your normal user is going to be medium, and then your goal is going to be to achieve, high or higher. So like I said, when we're researching UAC, we're more interested in, obviously, just the high integrity and medium integrity security access tokens. Again, high integrity equals administrator, medium integrity is going to be the normal user context. So there are various UAC levels. I'm sure a lot of you are pretty familiar with them, right? So you've got always notify, which to most people, for whatever reason, means that like they're completely okay and that their user is fine being in the local administrator group if this is set. You've got just notify with secure desktop and notify with secure, or with no secure desktop and then never notify. So the default is going to be notify, that middle one there. All the way at the top is always notify, and then all the way at the bottom is never, or like don't ever notify. Again, default is notify. So a user is a local administrator. An attacker lands on that host. That user is sitting in a medium integrity context. UAC is set to default level. So an attacker has to somehow find a way to jump up an integrity level so that they can actually, do what they need to do as far as, dumping crud, stuff like that. So the next component here is kind of the bypass research. So what are attackers doing? What are researchers doing to get around, this feature? One thing I will note is that it's a required thing to get around for attackers, right? So when an attacker has an objective, like that's why they're in your organization, UAC is just going to be a small little barrier that they have to overcome. And this talk is more of a tradecraft focused talk. There are no vulnerabilities, there are no exploitation, there's no exploitation going on. It's just highlighting the high level overview of what attackers are doing to circumvent this in order to keep moving along their chain. So ideally, a user would like to, or an attacker would like to do this elevation without alerting the user. So if an attacker alerts a user during elevation process, it's going to tip the user off. They might say something. It's risky for them, right? So the ideal situation is going to be to elevate silently. One thing that I've been seeing kind of a lot of is these GUI bypasses. If you're interactively logged onto a workstation and you're able to click on things, there's no bypass, there, right? So don't be this guy. Don't open the yeah. Don't open the task manager, right click, run as, new task, set it to run as administrator, and shells, right? At that point, you can just click yes on the approval prompt. There's no real potential there. So I just want to set the scene for that is elevating up is going to be something that an attacker has to do silently. And if they can interactively log into a host, being quiet, it's relatively out the window there. They could just click on yes. So elevation objects, for the last, as long as probably way before I was even born, that's for you guys. Finding bypasses typically involves finding some sort of object that elevates silently and then abusing that object to get your own code to run. So in Windows, there are a bunch of processes that they're set to auto elevate silently. And this really only applies to that default UAC setting, right? So the idea here is to enumerate these processes. They can be scheduled tasks. They could be processes. So Windows will have each executable typically will have a manifest in it. That manifest will determine, hey, is this Microsoft signed binary that's running out of a system protected location like system 32? Is it set to auto elevate? If it's true, anytime that the executable is ran, it will elevate up to high integrity without requiring the user to allow it. So some common ones are like event viewer, task manager, stuff like that. So once you identify these various components that allow you to elevate silently, you're going to want to abuse those in some manner. That being, registry keys, file rights. There's a lot of really derpy stuff that we'll go over in this presentation as far as that goes. So when looking at the manifest, you can do this with sigcheck tac-im. You can see here that the manifest for eventviewer.exe has the requested execution level as highest available. Then the auto elevate property is set to true. So what that's saying is when UAC is in its default state, anytime that a user runs eventviewer.exe, it's going to silently elevate and display the event viewer for the user without requiring the user to click yes on the prompt. Pretty straightforward. So the idea or the methodology behind that is to identify these processes and identify, what are they doing when they're ran. So a good program to do that with is Process Monitor. So this allows you to see, for the most part, what all the process is doing as far as registry reads, file writes, file queries, registry queries, stuff like that. So this is just one example for SDCLT, which is one that I blogged about. When a binary elevates and it's reading from the registry, in most cases, it will read from the current user hive. So it's kind of taking, or it's abusing the primitive of a process that's elevated up silently, is reading or pulling information from a location that you as a normal user who's not elevated can tamper with, right? So in this case, it's pulling this isolated command, I think. Nope, app paths, sorry, wrong one. That was a different one with this binary. So app paths is just saying, SDLC when it starts, what am I doing? I need to start control.exe to open up a control panel item, right? So when this happens, it says, okay, I need to find the application path for the control panel, control.exe. It's looking in the user hive, so you can hijack that and say, cmd.exe is now control.exe. So when the program that's elevated up is looking for the app path of the program it needs, it's going to say, I need this. It's going to look in the registry. Once you change that, it's going to take whatever you give it, right? So instead of the legitimate value, it's going to start whatever you put there. So that's just kind of a primitive. So finding these via process monitor, the way that you can do that is just filter down to events as name not found, and then filter that down to any queries happening in HKCU or the current user's Hive. And that will give you a pretty good idea of what all that particular process is doing in an elevated context to a location that as an attacker you can control. So like I said, after you've identified these particular objects, the next step would be to abuse them. That would be doing a registry write to that location, putting your payload in. Again, bypasses are variant in the sense that there are many objects you can abuse. There are many things that you can do to abuse these objects. So registry key additions are kind of the new thing. You've got event variable manipulation, which James Forshaw did a good post on recently. And then race conditions, which is kind of a fun one that me and Matt Graber worked on. So this is just an example of abusing that same one that we looked at in Procmon, right? So it's querying the user Hive for the app path for control.exe. We've replaced that with cmd.exe, and then we started that binary. And since that binary, when it starts, it's saying, okay, my next job is to pull from the registry. I need to start control.exe, sees cmd.exe there, and then just uses that. And here you can see here that we are actually running as an administrator here. So that's kind of the generic overview. That is kind of a methodology for the registry manipulation portion of it. There are hundreds of other primitives as far as this goes, which is why it's not something that can be easily fixed. It's not something that will be fixed. The fix is to not be dumb and pull your accounts out of the local administrator group. So bypass evolution. I started developing this deck, and I was like, I'm gonna do an entire history talk on UAC bypasses. And I started looking, and I was like, this deck's gonna be like 420 slides by the time I'm done, and I don't want to piss anyone off as far as credit goes. So I'm gonna go over just some generic ones. This isn't gonna cover all of them. This is gonna cover some of the more prominent ones that have been used in the wild, at least from what I've seen and heard. If you're looking for some sort of definitive list of public bypasses that are out there, Firefox has a really good GitHub repository of all of these documented bypasses, if they've been fixed, what versions of Windows do they work on, and he's got a POC binary that implements every single one of them. And you can just run it and give it a technique, and it will execute it for you. So kind of a cool little thing as far as playing around with. It's the only source that really accurately and maintains a comprehensive list of these. So definitely go check that out. Like I said, not covering every bypass technique. I'm going to cover just kind of the tradecraft around some of the newer bypasses and from an operational security standpoint that attackers are facing, how these various bypasses might be safer or more noisier than others. So the first one's the good old iFile operation. So this is the one that's been around since 2009. It's been the default one in almost every malware sample that has some sort of module to get around UAC. Created by Leo Davidson, again, back in 2009. It still works on the vast majority of endpoints. So Microsoft actually fixed this in Windows 10 RS2 and build 15007. Which will cover why they fixed that, and like I said, it's not a boundary, so why are they fixing it? I'll kind of explain that here in a little bit. So the way that this works is that iFile operation is a COM component that allows you, it has a method called copy item. And what that does, it allows you to copy an item from one location to another. Straightforward, right? The caveat to this is that technically, in order to invoke this specific app or object and then call that method, is you have to be running inside a Microsoft signed, certain whitelisted binaries. So a common one's explorer.exe. So the way that this attack actually works and the way that he released it was that it injects or it spawns a new process or injects into an existing one, a DLL or reflective DLL that exposes this interface and this method. And this object is one in particular. So like I said, there are many different primitives as far as things that auto-elevate. Various COM components are one of them. So there are COM objects in Windows that are permitted to elevate silently. This being one of them, given the certain circumstances that are required or met. One being, that it's living in a process that it's expected to. So you've got a primitive right now of a privilege. This is what I call privileged file copy. So you can copy one file to a protected location silently, which is good, right? So far this technique involves potentially starting a new process, injecting something into another process, which can be noisy or risky. And then you've got to actually do your file copy, which is going to involve dropping your payload, which is going, in most cases, going to be a DLL. Drop that to disk someplace that you can write to without being elevated. Call copy item, take that DLL that you dropped and copy it to a privileged location. So you might be thinking, how might you get codecs through that? How are you going to get your code running in an elevated context if all you can do is copy a file? Normally, how many of you defenders have rules to see if a DLL called cryptbase.dll is dropped in C Windows System 32 sysprep? That makes me sad, no hands. Okay. That got me caught a lot of times. So the way that this works is attackers are lazy, they don't modify code. Sysprep.exe is an auto-elevating binary that elevates up silently without alerting the user in the default UAC setting. And it looks for a DLL in its current directory called cryptbase.dll. That DLL doesn't exist in Windows. It will probably never exist in Windows, and it never has existed in Windows. Meaning that you can use that privileged file copy to copy a malicious DLL from a location you can via an auto-elevating COM component, copy that file over to sysprep, the sysprep folder, call it cryptbase.dll, and when you start sysprep.exe, it's going to silently elevate, and it's going to eat your DLL and load your code. So this is hopefully everybody can see that. So FuzzySec released a cool little framework for automating some of this. So this is just what it looks like. I have a link towards the end of the presentation that contains some references as far as this goes. He just ported, utilizing the iFile operation, COM component in PowerShell. I'm using some really cool PE masquerading work. So what this does is, again, it just copies it towards the bottom. You can see that it's dropping the proxy DLL. Then it's doing the privileged file copy, dropping that into sysprep, calling cryptbase.dll, and starting sysprep. So from a forensic standpoint, you're going to see a file being dropped. You're going to see a file being copied to a protected location, which that's not normally going to be a thing, right? You're going to see that, and they're going to see sysprep.exe start, eating a DLL that it has never consumed before or that has never existed. I'm not a defender, so I don't know definitively, but I can't imagine sysprep.exe starting in your environment would be a totally normal thing. But this is still the go-to method for damn near every single adversary that has UAC bypass modules. This has been the de facto technique for since 2009. I got a little tired of it, and so that kind of what stemmed some of the research in the last few months, particularly. So another finder called Vazi used the same primitive of a privileged file copy in a different way. So he removed the need to do injection. So there's a built-in utility in Windows 7 and Windows 10 called WUSA. So it's the Windows Update standalone installer. Typically it's used for extraction and stuff as far as installation or update files goes. This is also an auto-elevating binary. So in its manifest it says that it is permitted to auto-elevate without the user's approval, given that it's sitting in a system protected path, so system 32 or wherever it may reside. They removed the extract flag out of Windows 10. Reason being is that you could do a privileged file copy with this. You could cap up your payload, throw it in temp, and then call WUSA to extract that cab to a location in system 32. So you're using the fact that this binary is automatically elevating, and then you're using that to extract your payload into a protected location that you might not normally be able to write to. So that gives you another file copy primitive, right? This is an example. So again, this is something that I ported with obviously Vozi's original POC written in VB script. So you're cabbing a manifest. The way that this kind of abuses, you might say you've got a privileged file copy, but what do you do, right? So dropping a DLL might not, it's sysprep's also let me pause this guy or not. That's fine too. So the way that this works is that it actually cabs up a manifest file, and then it copies that to C windows. And this manifest file, we talked about manifest files and how they, when they're embedded in a binary, if they're running out of C Windows System 32, and they've got auto elevate set to true, they're going to be allowed to elevate up, right, silently. The bug here is that wscript/C script does not have an embedded manifest, meaning that when a binary doesn't have an embedded manifest and then you drop one in that current binary's directory and you start it, it's going to say, hey, I don't have an embedded manifest, it's going to eat the one that you provided. So how this actually works is that we're cabbing up a manifest for wscript. That manifest is going to say, hey, I'm allowed to elevate. It's going to have auto elevate set to true. We're going to cab that up. We're going to extract it using our privileged file copy with WUSA. Once that is done, we have planted this manifest in C Windows. We're copying wscript from C Windows System 32 over to C Windows, and we're starting it. So when wscript starts, it's going to say, hey, per my manifest and my other requirements of me running in a protected directory, I'm able to silently elevate without popping a UAC dialog. So now we've got the ability to start this wscript.exe binary, right? So what do you do with that to get code execution? Well, I'm sure many of you know that you can run VBScript or JScript with that. So this just shoves a payload in an alternate data stream, does a privileged file copy for that manifest, starts wscript, reads that data stream in, and you get codecs from there. So this is just showing here that after we've executed it, that we've started cmd.exe in a high integrity context. So this is my favorite one. This kind of opened up a class of attacks that I don't think a lot of people publicly have talked about, and that's registry verb handling modification. So when a process starts, and it's typically when you double click on a process, you start a process that's via the open verb. You can do things like when you do right click run as administrator, that's using the run as verb. So there are various verbs that are registered in Windows. There's the print verb when you right click on something and do print. And that's just kind of a shortcut saying, when this verb is invoked, go to the registry and see what do I need to do here. So the open verb is typically mapped to whatever invoking process. So for example, eventviewer.exe has an open verb set to mmc.exe with the path to the event viewer MSC or MMC snap-in, right? So eventviewer.exe does not actually just start the event viewer. It calls mmc.exe, which is the management console, and then passes it the path to the event viewer snap-in. The cute thing about this is that this is what it looks like. So it's just saying mmc.exe when an MSC file is opened. MSC files are associated with what? mmc.exe, because MSC files are console files. So this is just saying when an MSC file is invoked, this is going to be what we need to do. We need to run mmc.exe and then pass it the path to that MSC. This is what it looks like in procmon. So you can see that we've started eventviewer.exe, which has a manifest saying, please auto-elevate me because I'm special, I have auto-elevate set to true, and I reside in a protected directory. When that starts, event viewer says, okay, I need to start event viewer somehow, and since event viewer, I'm nervous about Kennedy coming in and seeing me. When that happens, it's going to say, okay, I need to open this MMC snap-in. The file format for the snap-ins are MSC, so it's going to go to the registry and say, okay, MSC files, how do I handle those? And the registry is going to say, well, when you look at the shell open command value, it's going to be the MMC program, right? Perfect. So when you start a process that elevates silently, and then that process invokes another process, it in most cases inherits that integrity level. So most processes are set to in their manifest, the elevation is going to be as invoker. So it's going to run under the same kind of components as that invoking process. That's what's kind of happening here. So it's looking in our hive, which we can control without being elevated. it's going to say MSC files, how do I handle those? Looks at that value, and it doesn't exist, so it moves on to, through the particular registry, the registry search order. It's going to move on and say, okay, now I need to look in HKCR, HKLM, I need to see what is the actual binary. We can give it that value, and what actually happens is it loads it up for us. So I scripted this up, you just give it a command you want to run. This just adds the actual payload to the registry and that registry path. When event viewer.exe starts, it's going to read that from the user hive, and it's going to pull that. The glory about the command, so you can see here that the rcmd.exe said, God dang it.
Your choice.
But what if I ban?
Oh, you got banned? How many you got?
Enough. Not as nearly as much as that. Well done, sir.
Where's the romper?
It's right there. I'm wearing it to the bar.
All right.
Yeah. You'll see it. Trust me.
All these people are running.
Yeah.
Here's a view.
I showed it to
Later
him.
on. There you go.
Thanks, man. All right. I'm not going to chug this because I'll die. Oh, Lord. All right. That is raunchy. All right, so, yeah. Do the registry hijack, start event viewer. It's going to read that as us, and then with these specific command or these verb handlers, you can actually give it a binary and any parameters. So here we can just do like PowerShell.exe, tach enc, and give it our payload. It can be whatever you want. Here is just a PowerShell command that started cmd.exe. And then all of the really skitty malware authors were like, this is the coolest thing since sliced bread, and now everybody uses it. So John Lambert is, he works at Microsoft leading some of their, various malware and intelligence stuff. He likes to constantly remind me that I'm a piece of crap for publishing code that all the bad guys are using. So he likes to tag me in these. And that actually prompted Microsoft to fix the first bypass that I've at least seen. Historically, they've not ever fixed a bypass, at least to my knowledge. My UAC bypasses have been around obviously longer than I've probably been alive. But this is the first one that they actually fixed. But they didn't fix it by backporting it to other versions, right? They didn't service it. They didn't CVE it. They didn't push it out in their bulletin. They just added it in a new build. So while they were doing the development of this new Windows build, they said, hey, we need to fix this. And they fixed it and they pushed it out. So cool, right? Their mentality's starting to shift a little bit. I think what they're starting to see is that it's still a thing. People still care about it despite it not being literally useful whatsoever in Windows. People still care about it. Attackers still care about it. Attackers still use it. And so they ended up fixing this one. And that started a triage of them fixing them, which makes me want to keep the ones that I find private. And then James Forshaw was like, USC is stupid. And then he put out a 3-part blog post that more or less kills the entire technology for the end of time, which we'll talk about here in a little bit. So this is a fun one. So like I said, we've got various primitives, right? So we just did some privileged file copy ones. This one is a race condition, which is a rather unique one. And part of me kind of questions some design decisions, and I'll explain why here in a second. So when a scheduled task is created, you have the opportunity to set some properties that allow it to run with the highest privileges in Windows. And what this will do is, so the previous ones they worked in the default UAC state, but they do not work in auto-elevate or always notify situations, which is why, people are like, these are cool techniques, but in my company, we set it to always notify, and we're totally safe and secure, and none of this matters. Always notify bypasses are a little trickier to find because those binaries that do not, that set to auto elevate, when always notify is enabled, it will notify regardless. So that kind of kills the primitive of abusing those auto elevating binaries for elevation, since the user is granted or provided an elevation prompt regardless. Scheduled tasks, on the other hand, when they exist and they're set to run with the highest privileges, they execute with highest privileges without like alerting the user. So there is no prompt when a scheduled task that's running under the current user context or set to run as an interactive user with the highest privileges
It'll elevate silently. Ugh. Okay. So what this does when the scheduled task is ran is it creates a random folder in the user's local app data temp directory. Sketchy, right? It then copies certain files there and then does some really dumb things. They fixed this in Windows 10 RS2 15.031. So pretty, let's see. Actually, that was the same exact build. So in one build, they fixed, you know, two elevation primitives, more or less. So again, that was fixed. So here's how this works: is when you start that scheduled task, it's called disk cleanup. And what it does is it's designed to clean up your system, which it has to be elevated to do that, right? You just run it and it cleans files, all these temp files for you. If you proc mount it, you'll see that it's creating a file and see users mat, app data, local temp, random folder, and then, is that a DLL? Yeah, that's a DLL. So log provider.dll. So why are you copying files as an elevated context to the user's local, you know, app data temp folder? Why not just run them out of the directory they exist in a protected spot, right? So sure. We can then see that it actually copies dismhost.exe to that same folder, which we can write to because it's our local app temp folder, right? So it's copying dismhost up, and then it is starting dismhost. So like I mentioned earlier, when an elevated process starts another process and it has as invoker set, it's going to inherit or it's going to start in that same context as the invoking process. So we now have this dismhost.exe running out of our temp directory. Kind of weird. All of this is obviously with you know, always notify set. And then we can see that it starts loading DLLs in that current directory. So we can, if we can beat the mod load of that high integrity process, or dismhost.exe, we can monitor, or how this bypass actually works is that there's a WMI event subscription that monitors for that folder being created. And once it is created, it will copy the last DLL. So this took a little bit to figure out of like which DLL does it load last. Copies our malicious one up there with that same name and just lets it sit. By the time dismhost.exe goes, you know, it loads all these down and then it eventually loads our module. This is just an example. You can see that we do our privileged file copy, and we are now high integrity. So environment variables are the same thing. I won't spend too much time on them because I'm kind of running a little bit low on time. More or less, that there's the same scheduled task it uses environment variables to determine where this clean manager binary is going to run. It reads that environment variable from the current user environment hive. We can do that and say we are now creating an environment variable called winter. Give it the value we want. So you can read more there. That's by another one by James Forshaw. Go ahead and skip that guy. So COM hijacking. I'll post these videos afterwards as well. So COM hijacking. This is kind of an interesting one. So without going on a rant of various COM components and how they're registered, COM servers are registered either in HKLM or HKCU, and the COM servers are like inproc server 32, server local server 32, and server keys, and then that's either the DLL or the executable that represents the COM server. As you can imagine, certain binaries will load COM servers from the user hive, event viewer being one of them. So event viewer, like we talked about earlier, it auto elevates silently. And then this time it's actually looking in the user hive for this class ID of a COM server that it's expecting. And the key is actually, that random string and then the server. But the hijack primitive here is going to be to just write a value of our malicious DLL, which is going to be, whatever malicious COM server we want. And then when we start that, it's going to execute. So here, it's just a simple reg change. We are saying this class ID or this COM server, when you resolve it, it's going to point to our COM server instead. We import it, we start event viewer.exe, and it's going to load that for us. So this is the one I want to spend the most time on because all that's cool and nifty, and there are all these little primitives you can abuse, and none of that matters Bypass research for UAC at this point, in my honest opinion, does not matter anymore. And the reason being is that, again, James, are you in here? There he is. Let's give a round of applause for James for all this awesome research. Yeah. So he did a three-part blog series on reading your way around UAC, and this puts the nail in the coffin as far as elevation goes, and how attackers can actually elevate their way up. So he did a blog post, and then Fuzzy Sick implemented it or weaponized it in a PowerShell script, and so with this technique, you can forget finding all of those auto-elevating objects. You can forget finding, binaries that have auto-elevate set to true in their manifest. You can forget trying to find, scheduled tasks that auto-elevate for you. You can forget all of that. The way that this works is that when a high integrity, or a process with a high integrity security access token is started, the normal user, it's in the same logon session, so a normal user can actually access that token, that process and token. So the way that this actually works, so it does get around always notify silently. There are like 1 or 2 always notify bypasses. One of them James put out for Windows 8.1 a few years ago. The other one was that disk cleanup one, and those are kind of really the only 2 that existed for a while. This completely gets around any version of UAC that's set. Oh, I don't go back. So you identify, the way that this works is you identify a process that is in the context that you would like, right? So one that's in a high integrity context. And since you are able to access or get a handle to that process, you can call open process through the Windows API, get a handle to that process, and then you can do open process token to actually open the token of that process. Once you have that, you can call duplicate token EX, which will duplicate that token for you. And then you can do some SID stuff, and then lowering the token integrity level, and then filtering the token so that you can actually apply it. And then you call duplicate token EX on that new lowered and filtered token. And now that you've got that, you call create process with logon W, which is another API, which allows you to start a process with that token that you have just stolen from that other process, right? So that takes any process that has a token that is elevated, you can steal it and then start your own process with that token. So you don't need, you need no additional, registry rights, no file copies, none of that crap. So from all of the other ones, we were changing registry. So it went from the dirty version, right? Dropping a DLL, copying that DLL to a protected directory, starting a process, super, That went to just making a registry change. So a little safer, but not super cool. It's maybe a little bit better. So we went from that, so dirty to still pretty dirty, to you don't need to drop a file if you don't want to. If you want, you can drop your payload or your code that's going to get executed on the file system, and you can pass that to create process with logon W to start it up as elevated. But you can do regsurf32, PowerShell, WScript, whatever your heart desires, without actually having to put that payload itself down. So this is the most OPSEC way of actually elevating without having to make any real OS changes. So this is what this looks like. So you can see that it's set to always notify. I did a port. So we'll pause this guy here. So I actually ported it. So when Ruben did the original POC, it used add type. For those of you that aren't familiar with add type, it allows you to dynamically compile and load C# through PowerShell. As I do red team work in my day job, and so like dropping files down, like using add type, kind of makes me cringe a little bit. But it was an incredible starting point. So I get a hat tip to Ruben for taking this incredibly crazy, amazing 3-part series blog post that James put out and actually weaponizing it for us, right? So he did the dirty work. He did all of the heavy lifting. All I did was I ported it to PS Reflect. So that was Matt Graber, Jared Atkinson. It's a framework that allows you to initialize and kind of define API structures and functions in memory using PowerShell. That way you don't have to compile that in C# and then load it. You can do it all in memory. Ported that, and then I added some looping. So previously all you had to do is you had to give it a process ID. The issue that I ran into there is operationally is running in an implant, I don't have a super great way, or I didn't want to spend time developing a super great way to enumerate what process do I want to use? So as a medium integrity context, I need to identify a process I can actually use to steal a token that'll be useful for me. I couldn't do that, so like I don't know what else to do here. So what I ended up doing was implementing a few other API calls, and what it will do is it will loop the process listing. It will enumerate the tokens that are applied to those processes, and if it finds one that has that high integrity level that we need, it will use that process ID. If it doesn't, it'll check to see, hey, am I Windows 7? Yes, you're kind of SOL. If you're not, it'll try to abuse some disk cleanup stuff. We use this on an engagement where they had always notify set. When users are logged into their machines and they have always notify set because their security department knows that UAC is the devil and like they have to have this up, users are going to elevate, right, at some point. It's just the nature of it. Anything they do, they're going to get alerted for. Typically, they'll click yes and they'll go on with their life. Windows 10 actually has some stuff that goes on in the background that actually elevates by itself for you. So this will just loop the process listing. You can set it, or you can change it so that it does a continuous loop, or you can just do a once over loop. Enumerate the process listing, find a target process, and it will actually steal the token from that process. And that's just what it looks like there. So. Again, you can find UAC token magic by FuzzySec. This is the original POC that uses add type. The link to James's posts are in the reference section of this post, as well as 2 slides back, which you can go read the very, very low level details of how this actually works, because I probably did a terrible job at explaining it. So all I did was I took that original concept, changed, took Ruben's heavy lifting and implemented it in NPS Reflect. Makes it more safe to use. So you can find that here on my GitHub, invoke token duplication.ps1. Again, like I said, it just enumerates the process list, finds the target process, steals that, and then calls create process with logon w, which will give us code execution, or the ability to start an arbitrary process with parameters in the context of that new token for us. So mitigations. Like I said earlier, every environment that I've ever been in has at least a handful of users that are local administrators. And it takes everything in me to not smack like the people on site when I see this, because this shouldn't be a thing, right? Users don't need local admin rights, so just don't do it. So the mitigation here is to stop running as a local administrator. I can't say it enough. I get a little more depressed every time that I go on an engagement, and I have to actually elevate myself because these users are local admins. So practice real least privilege. Have separate user accounts. Over-the-shoulder elevation seems a little fundamentally broken, so James talked a little bit about it in his blog post. So just practice, decent least privilege. Don't just don't throw domain users in the local admin group for every host and call it a day. So just special thanks to James, Ruben, so FuzzySec, who did a lot of the heavy lifting for porting James's awesome work, Matt Graver for putting up with my dumb questions and helping me out with the race condition, and obviously Firefox for maintaining a really good list or repository of these bypasses, and then all the other people out there that have continued the research. So over probably the last year and a half, there's been a re-owned spark in UAC research. So a lot of people have come out. And they've gained some sort of interest in looking into this stuff. So while the token stuff is amazing, I encourage people to use UAC as a case study. So if you're wanting to get into security research, or you're looking at something to start out that's not super crazy, this is a good one. It's a pretty easy technology to get around once you kind of have your rhythm. So if you need something easy to start on, UAC is a good one. Helps you learn Process Explorer, Procmon, how Windows works to a degree, how registry works, stuff like that. So it's a really good starting point. Just because obviously the POCs or the techniques for elevating are now kind of null due to the token stuff. Definitely go out and still explore some of these bypasses and find your own, just to get in that mentality of thinking